All right, example 1. Use the vocabulary information to answer the following questions. So given the polynomial f of x equals x cubed minus 3x squared minus 5x minus 25, answer the following questions. First one, number of solutions. That is equal to the degree. So in this one, it's going to be 3 solutions. The maximum number of turning points is your degree minus 1. So in this one, it's going to have 2. Then, if negative 1 plus 2i is a solution, what must another solution be? So we talked about the imaginary solutions come in pairs where they're conjugates, where one is going to be a plus the imaginary part and one would be minus the imaginary part. So if negative 1 plus 2i is a solution, negative 1 minus 2i would also be a solution. So if negative 1 plus 2i is a solution, how many real solutions are possible? So because we know negative 1 plus 2i is a solution and negative 1 minus 2i is a solution, and we can only have 3, we would have 3 minus the 2 imaginary. That means that there's only one possible real solution. So it's just going through and eliminating the other options to see what your possible answers are for the real parts. Okay, the next 2 problems you are going to need a graphing calculator. So if you don't have one yet, go grab one because you are going to need to practice on your graphing calculator. Let me split this. Okay. So we're going to graph this. So to start, you hit the y equals, and then you type in your equation, negative x to the power of 3. And we went over that last chapter, so hopefully you remember how to type in your equations. Minus x, and then minus 4. Okay. And then we are going to graph. All right, so I have my graph here. They want me to list any zeros. So we went over that last chapter, how to calculate a zero. You hit second, and then that trace button, and you go to number 2, and you have to go to the left of the 0. So 1 is going to be above it and 1's going to be below. So to the left of this first 0 that's close to negative 1 is going to be above it. So I hit enter, and then I go to the right of it, which is below it, and I hit enter again. You don't have to guess. So one of my zeros is going to be negative 0.8, and you can round to the nearest tenth. So one place after the decimal point. Now I'm going to find my other zero. So I hit second, trace number 2, and I go over to my next one. This time, the 0 that's between 1 and 2, to the left of it's going to be below the x-axis, and then I'll go to the right, hit enter, and then my other answer is 1.5 when I round. And then I find my last 0. And there we go. That gives me 3.3. Those are my 3 zeros for this graph. Next, we're going to find any local maximums and local minimums. And again, for those, we only have to list the y values. So here we're going to list y. Okay, so maximum is the top of any curve. So we have one that is over on the right side of our graph. To calculate those, it's the same starting step as the zeros. You hit second and then trace. And you're going to see at number 4, it's the maximum. So you're going to push number 4. And just like when we find the zeros, we have to go to the left and then the right. So we're going to go to the left side of that maximum and hit enter. Then you're going to go to the right side of that maximum, so on the right side of the hill, and hit enter. You don't have to take a guess, and then it gives you your maximum. Remember, we are listing the y values, so not the x, the y, which is above the zoom button. So our local maximum would be at 2.9. And there's only one, so that's our answer. Then we do almost the same thing for the minimum. We hit second, trace, and minimum is number 3. So now we need to go to our minimum, which is at the bottom of the curve. We're going to the left of it. So on the left side of that curve, we hit enter. Then we go to the right side of the curve, hit enter. and then enter one more time. So our y value for this would be negative 4.1, and that would be our minimum. All right, then we have our domain and range. Remember, our domain is our x values, which is always all real numbers. Our range, this one has an odd degree. So if we look, our graph continues to go up and down. So that means it's covering all of the y values. So y would be all real numbers. Okay, so you should pause the video, try the next one on your own, and then skip to the end to see if you got the right answers. If you're still confused, you can follow through as I type this in. So this one, you hit y equals, clear it out. We do negative x to, oops, didn't type the negative. So negative x to the power of 4. And then plus 2x cubed plus 2x squared minus 3x. Graph. Okay. So again, we're going to find our zeros by hitting second trace, number 2. This one has 4 zeros. So I'm going to start on the far left. I hit enter below, and then I'll hit enter above. And for your zeros, you're listing the x values, negative 1.3 about. Then I'll find my next zero. Hit enter, enter, don't need a guess. So we have another one that's at exactly 0, so I don't have to round that one. And another one that's at exactly 1. So sometimes you will get nice numbers, not always, but sometimes you do have solutions that are whole answers. And 2.3 would be the last one. So this one I have 4 real solutions. Then I'm going to find my local maximums. It looks like I have 2 curves that are opening up, so I'm going to find both of them. So remember, you go to the left of the curve and then to the right of the curve. And you're listing just the y values. So the y value on here is 2.25. Because I don't need to round that one because it ends, I'm just going to write the whole number. Then I'm going to find my other maximum. So I'm going to start by going to the left. Oops, too far, sorry. So the left of the curve, and then I'm going to go to the right of the curve and hit enter again. And that one is exactly the same. So I'm going to write them both down so I remember that I did check them both. But if they are the same, you don't have to write it twice. Then I find my minimum. So I hit second trace again, number 3. And I go to the left of my minimum, that downward curve, and then my right side, and that gives me negative 0.8 about for my local minimum. Then for our domain and range, remember domain is always all real numbers. For my range, however, this one has an even degree. So that means I have to write an inequality. Your inequality is going to be written with your minimum or your maximum value. So if we look at our graph, the highest this goes was that maximum point, which we said was 2.25. And then our graph goes below 2.25. So because it's going below that, that means our y has to be less than or equal to 2.25. All right, and that's how you do the calculator to help you find these values on the graph. The next one is going to go over how to sketch some graphs.